All right, here we go. First lesson of the week. So, as always, we start off on homework corrections. Here was your homework. Here's what I need you to do. I need you to pause after I give you the instructions. Pause the video. Go answer question number one on the form. It says, "Did you do your homework?" Just give me a yes or no. Once again, the entire week I'm not going to be collecting homework. Most days I will be calling out the answers and have you correct. But since this homework involved drawing everything, I would need to see your drawings to tell you right or wrong. So just need a yes or no if you did your homework. And yeah, it will go in the grade book. Lastly, if there was a question you specifically had a question on, you had trouble with, shoot me an email and I'll give you an answer or give you some assistance. Okay, so pause the video, answer question number one. Okay, with that done, calendar, once again, we're not doing a chapter test. We will do on Wednesday a chapter review. I'll give you the I'll give you the questions. You'll do the questions just for this class. No homework that day. We'll try to knock out as many questions as we can in the 15-minute class. And then I'll make a video, and basically the video will just have me doing the problems, showing you the answers, that sort of thing. And then we'll move on to chapter 11. The calendar does say PSAT prep for the following week. I'm not sure if that's 100% true, if we're going to do that, or it'll be the following week. They're still ironing out the schedule, and who knows with the coronavirus what could actually happen. But for right now, that's the basic plan. We'll do a PSAT prep that week, and then that following week will be the PSAT test itself. Okay, tonight's homework, as listed, as normal. And remember, as we go through the video, you absolutely have the option of pausing the video, rewinding it, that sort of thing. If you remember, the previous class was literally the shortest class of the year. This will be the second shortest class. This is a pretty short class. Technically, there's really nothing I'm going to show you today. It's basically taking what we learned in the last section, 10.6 on loci, and applying it. Locus is what we really did last class. This one's going to be loci problems, so ones where we have multiple conditions. Okay, so it is called locus problems. It's really more loci than locus. So we're just going to see if we can satisfy the loci conditions, meaning that I'm going to give you two or more conditions. You need to come up with what they have in common. Last class, we started off with the concept of locus. That's the set of points that satisfy one or more conditions. If it's more than one conditions, we say loci. So we're just going to jump right into it. Quick review for the locus. Okay. One more. This is the one that we did on Friday as well. You're given a segment, AB, and a set of points that are 1 centimeter away. Well, there's clearly points 1 centimeter away on that side of the segment. It also doesn't say a plane here, so therefore that 1 centimeter away would go in all directions around segment A, and that location as well too, and that location. And so it would appear just from that it would make a cylinder, but that's not really the answer because on the two endpoints, let me see if I can illustrate. So the two endpoints right here, those would also have to be 1 centimeter away. That's a pretty crummy drawing, but you get the basic idea. So in other words, long story short, what it would make would be basically a pill, I don't know, a hot dog shaped, something like that. Okay, it certainly doesn't make a sphere. Okay, so there's our locus example. Today we're going to be doing loci. So write this down somewhere in your notes. Book of truth. A loci, notice it doesn't say locus, it's a set of points that satisfy two or more conditions. Locus was one or more conditions, so loci is one where we do plural conditions. Set of points that satisfy two or more conditions. Now we are only going to do one example. Hopefully you get the concept from the one example. If not, feel free to email me on any of the ones that you have problems with for homework. All right, so let's knock out one example. Well, technically we're going to do two examples. I'm going to show you one example, and then we'll do one together. Okay, here we go. So let's see. What are we given? We're given that you have three non-collinear points. Three non-collinear points. So let's see. That's 3 points that don't form a line. And the conditions are, remember this is one where we get more than one conditions. On a plane, the set of points 1 centimeter away from A, there's your first condition. And you have the word and, so here comes your second condition, equidistant from B and C. So sometimes it's just easier to start with the given, so 3 non-collinear points. Now it doesn't tell us anything, how far away they're from each other, so you have lots of options, but there are 3 non-collinear points. Notice that these two would be on a line, but the third one were not, therefore non-collinear. Okay. 3 non-collinear points, done. Sometimes it's easier, rather than to try to think of the entire, if you try to think of the entire set of conditions, to think of them as one at a time. That's what I'm going to do. So I'm going to think of these conditions. Oh, this is the given, but I'm going to think of these conditions. Let's see. Here's the first conditions. The set of points 1 centimeter away from A. And the second one is equidistance, I'll put 2 lines, equidistance from B and C. So there's my 2 sets of conditions. Okay. All right, so I'm going to draw each one of those separately. All right, so there's my, let me get the right thing. There's my 3 non-collinear points. So if I were to do the first condition, the set of points 1 centimeter away from A, we did that one for homework, we did that one in class. We know that it's going to be a circle. Remember, it does say on a plane, so it would be a sphere if it was not on a plane. So there's the locus. Remember, one set of conditions. There's the locus of the points that are 1 centimeter away from A. Okay, so we've met condition A. And then what I'm going to do is I'm going to redraw A, B, and C. I'm just doing this because I think it's just mentally a little bit easier to think about it the first time you do these 2 things. There's no reason why you can't do it all in one picture, but just for sake of demonstration, I'm going to do it on 2. So let's just do the second condition on this thing. So let's see, I need the points that are equidistant from B and C. We also did this one during class, or it was homework. The set of points that are equidistant from B and C. Well, if we were to draw one point that's equidistant, clearly that point right there would be equidistant, right? Well, then so would this point would be equidistant. So would this point be equidistant? In fact, what you would wind up getting is simply you'd get a line, right? A line would be the set of conditions that are equidistant from B and C. Okay. All right. So what you're asked to do is you're asked to combine the first condition and the second condition. In other words, draw the first condition, draw the second condition, and what do they have in common? Or in other words, where do they intersect? Where do they intersect? They intersect at 2 points. And that, ladies and gentlemen, would be the answer to this question of what is the loci. The loci would be 2 points. Make sense? Anybody have an issue with that logically? Hopefully some of you are saying that can't be right always. All right, so what's the big but here? The big but is that we drew that specifically where A was located somewhat between point B and C. But point A could have been drawn anywhere. It could be drawn below, to the left, to the right. It just didn't need to be collinear. So it turns out that there's actually 3 things that can happen. Well, we just discovered one. All right, the loci of points that where A is kind of between and above point A, but is there any other way to draw A? Sure, I mean, well, there's the one for 2 points. A could be located above B. And notice if we did it this time, and we draw all the points that are equidistant from B and C, now we only have 1 point in common. Is there any other way that this could happen? Sure, if A was way far away from that line of equidistance between B and C, I mean, I didn't have to draw it there. I could have drawn it way far away, but there's your 1 centimeter away. And here's your points that are equidistant from B and C. And notice now they have no points in common. So this one requires, just do a whole lot of thought. Sure, we found out that, for this particular one right here, that it does have 2 points in common. But it also could have 1 point in common or no points in common, depending upon where point A was. So how do you answer these questions? So the real answer to this are those 3 possibilities. Well, it might have 1 or 2 or no points in common. So today for homework, these are going to be, you have to do a little bit of thinking of all the possibilities of what could happen when you draw the given. and you apply the conditions. Make sense? Okay, ready to do one? Yeah, ugh, right. All right, these will be challenging. Just remember, you always need to think about, are we dealing with 2D and 3D? And typically the key words are, if it's on a plane, obviously it's two-dimension. If it doesn't say on a plane, then you're in 3D land. All right, so here's what I want you to do. I want you to pause the video. I want you to read the given and the conditions. I want you to give it a couple minutes of thought. Maybe you need to do some drawing. And I want you to give your answer to this question. And this will be the answer to question number 2 on the Google form. So go ahead and look at the conditions. If you need to draw a picture, draw a picture. Some of you might be able to do it in your head. Long story short, give me an answer on the Google Forms, and then unpause the video, and I'll reveal the answer. Okay, so what did you guys come up with? This looks very similar to the previous one. The only difference is it does not say on a plane. So here's one possibility, right? If it's not on a plane, the points that are 1 centimeter away, now I did not draw a sphere, but the points that would be 1 centimeter away from point A would be a sphere. Let's see, does that make any difference? The other thing I'd like to point out is that, remember, 3 points will always be on a plane. So it doesn't say 3 non-coplanar points, because that's kind of impossible. You can't have 3 points that aren't on the same plane. You can draw 2 points, and that third point will always lie on a plane. However, once you make this condition right here, the sphere right here, now some strange things happen, because remember, this is a sphere. So going with my picture right here, well, let's see. There's the plane that all 3 of them lie on. So where is the point for the second conditions? Remember, the second condition is equidistance from A, B, and C. So before it was a line. Is it still a line? Is it still a line? So if you were equidistance on this plane between A, B, and C, you would be that point right smack there, right? Now, if you're equidistance from A, B, and C, and you're not limited to just a plane, it doesn't say on a plane, then this line, it's hard to draw, right? I could show you this in real life, but this would extend up and below the plane because we're dealing with 3Ds. In other words, I drew my dot in the wrong spot. In other words, you would wind up with a shape that that would be a line that went through the plane. Now, any point along this line, it doesn't look like it's equidistance from C and B, but remember, this goes above the plane. So the distance between there and the distance between there, right, would actually be the same. And obviously, it has to be the same distance from there. Now, drawing it in 2D, it certainly doesn't look like it's equidistance at all. But trust me, or think, in the 3D world, that would be true. Okay? Okay, so what we now have to do is we have to put together the loci of these 2 conditions. Remember, this is a sphere. So if I were to redraw this, not necessary, you could do this all in your head, but if I were to draw the sphere around point A, then it would look like that. And if I were to draw this line, which would be equidistance between A, B, and C, right? How many points would this line intersect this sphere? Now, remember, the definition of the sphere is the points, all the set of points that are the same distance away from point A. So even though we think of a ball as having a middle, the Earth having crust and the mantle, so forth, sphere only has just the points that are equidistance from point, or that are the same distance away from A. So basically just the surface. So how many places does this line cross? How many places does this line cross the sphere? 2 points. Anyone with a problem with that? Yeah, there is a big problem with that. Why? It's the same problem with the previous one. Is that, well, when I draw A between points B and C, it works out great like this. But point A could be way over here. Therefore, the sphere is way over here. Therefore, the line and the sphere never intersect. Or there could be that one special sweet spot where the sphere and the line only intersect in one spot. So I don't know how many of you put the correct answer, which is 1, 2, or no points. It's the same answers as the previous one. So yeah, there's going to be a lot of thinking going on. I'm not claiming you have to draw all 3 pictures, but sometimes that might help for the ones for homework. Okay. So one thing you can do to help you with homework is to eat a nice good ham sandwich before you do this work because you need some good brain power. Clearly, some of you may run into a problem. There's only 1 through 12. Obviously, the odd ones are in the back of the book. You can look those up to see if you're getting them right. But if you do run into any problems, don't hesitate to ask a question. Okay? So, once again, that was the second quickest class of the year. And it wasn't because this is an online thing. This really was a pretty quick class as well, too. So, good luck with your homework. And I'll see you tomorrow in class. I mean, at your home on your computer.